How's it going, everybody? And welcome back to our Cisco Enterprise series, where we are going to continue our section on MPLS, specifically MPLS VPNs in this video. We already configured VRFs in the previous video, and in this video we are going to go over a high-level overview of MPLS Layer 3 VPNs. This is essentially what it is we are working our way through this MPLS section in order to enable. So I'm going to walk you through all the individual steps and how it comes together, and then we are going to focus on getting some configuration in place and all the good stuff that goes along with it. So this is going to be one of those things where it's more of a review for anything more than anything else, and just so that everybody's on the same page in terms of the workflow and the specifics and things like that. Because the last thing I want to have you guys doing is not understanding the individual components that make up the whole architecture, and then being confused when you get to an exam or when you're trying to troubleshoot MPLS VPNs and you're like, well, I think Rob said it this way. The intention here is to try to make sure that everybody understands all the individual components and all that good stuff that goes along with it. So with that being said, let's go ahead and dive into a MPLS Layer 3 VPN overview. So how Layer 3 VPNs work. MPLS Layer 3 VPNs have two basic components. Separation of customer routing information, so we have the VRF, which we configured in the previous video. Different customers have different virtual routing tables. And then we have the IGP BGP run inside the VRF between the customer and the service provider. Then there's an exchange of the customer's routing info inside of the service provider core. So multi-protocol BGP through the SP network. Traffic is label switched towards the BGP next hops. Now there's a common misconception that if you're dealing with VRFs, you're automatically dealing with MPLS. And that is absolutely not the case. There will be times when you will configure a VRF and MPLS will not be involved at all. There will be times when you're dealing with MPLS that there won't be VRFs at all. They have their own unique place inside of the network. Now, is it possible to run MPLS without a VRF? It is. You can totally do that. However, it is not recommended to do it that way. I won't even really get into the specifics, but conceptually, if you're going to be doing VRFs, if you create a VRF on a router or on a set of routers and you interconnect those devices and they're all VRF, back-to-back VRF connectivity, and you're trying to do separation of traffic based off of network function virtualization, so you're leveraging a VRF in order to do that, that's fine. No MPLS is required for that. However, MPLS VPNs make things so much easier to work with when you're looking at it from the perspective of what we're trying to do. So the VRF in this particular case is basically trying to provide segmentation of customer A from customer B from customer C to customer D. That's really what you're trying to do. And that's essentially what we're going to be going through and trying to understand. Now, in a VRF Lite, all devices in the transit path must carry all routes in all VRF tables. In MPLS, only the PE routers need customer routes. This is accomplished through a couple different things, and we've already covered them, which is VPN v4 BGP, so it's a combination of the route distinguisher and the prefix makes the VPN routes globally unique. The route distinguisher being here is the main caveat, right? And then the MPLS VPN tag or label. The P routers only need to know how to reach the BGP next hop, and they leverage the BGP free core. Now, granted, yes, we did enable BGP on XR47 and R32 to be BGP route reflectors for the provider edge connectivity. However, themselves, they're not doing any internal routing that's BGP. They're not doing any routing to router 30 or 31. So there's no driver here that would indicate that there's the full mesh requirement to do a full mesh of BGP. We don't have that. Now, the high-level steps, we've gone over this a few times. This is just more reiterating what we've already talked about. you need to establish a label switch path or LSP between the PEs. This is done through a combination of IGP and LDP. So we've done a combination of both interface level configuration for LDP, and then we've also done it at the process level for IS to IS. We've done MPLS LDP auto config. So that's the first thing. You need to have IGP and LDP operational. Then there's the exchange of routes with the customers. This is technically a final step. So if we were to move this down to the very bottom, that would be more applicable. Then you have exchange customer routes with PE routes between PEs, iBGP plus MPLS VPN. Only PEs have BGP running. We've already done that through enabling BGP VPN before between our provider edges and the route reflectors, and then label switch between PEs. Data follows the IGP plus LDP transport label. And then you come back over here, you do some sort of PE to CE routing with IGP or with BGP, whether it's dynamic or static routing. So we have options there as well. Inside of the environment, we leverage multi-protocol BGP. So how do PE routers exchange VRF info? They leverage 4364, which is BGP, MPLS, IP, virtual private networks. The multi-protocol AFI, one being IPv4, and the sub-address family identifier of 128 is VPN-v4, or VPN, IPv4, or VPN-v4. So it's 1:28, so it's IPv4 traffic with the VPN-v4 label. Therefore, we have 128 is going to be our AFI, SAFI mapping value. So remember that. And that's what allows us to do VPN-v4 encoding. So we have our 8-byte route distinguisher, which makes unique per VPN or per VPN site. In this case here, per VPN. And we chose to use 10:10. And then there's a 4-byte IPv4 address, unique per VPN. So when you combine the route distinguisher with the subnet that you're learning from the customer, that makes the route learned globally unique. VPN-v4 includes MPLS VPN label, and that's what gets you have the VPN-v4 label. So one thing that it is easily equatable is that if you were to say this right here, IGP plus LDP transport, you'll sometimes hear the BGP label, right? If you're talking about label switching between PEs, you'll hear the BGP label plus the LDP label. You'll see some documentation out there that'll reference both. And what that's referencing with BGP is the PE to PE communication about a provider edge learns a route in from the customer. That learned route gets a BGP label associated to it, and then that information is propagated to the other PE routers. That is going to be your destination label for the remote PE to get to wherever you're going to go. The LDP label is your transport inside of the service provider backbone. So if you hear that term, that's what they're essentially meaning. Now the VPN-v4 NLRI, the network layer reachability information format, has a couple different fields. Right, you got your 8-byte route distinguisher, you have your prefix, and your length, you have your next hop, so what is your egress IP address, your VPN label. Regular BGP attributes stay the same. What that means is you have the option of doing traffic engineering. So you can do local preference and things like that. That's more of an advanced capability. We're only going to be dealing with one service provider, so we really don't have the luxury of being specific, but if we wanted to take advantage of that, we could. Controlling VPN-v4 routes, you have the route distinguisher is used solely to make route unique, and it allows for overlapping IPv4 addresses between customers. Then you have the route target. You have the import. What routes will be able to go from VRF into BGP, and what routes will go from BGP into VRF. Allows granular control when you leverage the import and export map, and you can be specific on a per prefix basis. Going back to the route distinguisher versus route target, route distinguisher makes the route unique. Route target controls which PE routers you're going to allow traffic to be learned in on. on a per VRF basis. And again, you can have multiple route targets per VPN v4 route, depending on what your propagation is going to look like. Again, with the route targets, you've got your 8-byte field. Format is similar to the route distinguisher. It's identical, actually. And VPN v4 speakers only accept VPN v4 routes with the route target matching a local VRF. Now, route reflectors don't require this. They will automatically accept everything in. However, there are scenarios where you can leverage the route target complexity to control how your VPN topology is built. So right now, we're going to be building out a full mesh or an any-to-any communication. Like I said, there is the ability of doing a hub and spoke where you're only going to allow, for example, on your spoke sites, you would only import routes from the hub PE routers, meaning that your PE routers are connecting to some data center or main location where routes should be coming and going. However, you won't be importing route targets from other PE routers connecting to other sites. So it could be very much a spoke to hub communication, and I've seen that happen quite a few times. So you might have a couple of spokes that you communicate with. So what I just described is more of a central services type of situation where you will only want to talk to a hub location or something like that. This is more hub and spoke, and central services usually come into play when you're in a migration or a merger and acquisition type of scenario, but those do come into play. We're simply going to be deploying a full mesh, and it makes it easy to work with. But if you wanted to go into like anything other than any to any, and you wanted to deal with, for example, being specific to which route targets you're going to allow in, and you define them on a per VRF basis, you can get pretty granular with your config. Now, what's interesting about it is when you do the route target configuration and you want to get into a hub and spoke design or like central services, when you import a particular VRF or route target, you're going to import everything from that particular route target value. You can get even more granular with the import map and export map. So basically a route map that you can associate to a prefix list that will allow specific routes to come through. So if you only want to allow RFC 1918, which is going to be more than likely anything you're going to want to import anyway, but if there's a specific subset of routes that you want to learn, you can create a prefix list that can be associated to the route map that will allow specific routes in, even though the route target would allow anything that's being advertised from that particular PE router. You'd be able to go in and summarize or filter out routes that you don't want to learn. So let's talk a little bit about the transport label versus VPN label. There are two labels to deliver traffic. Can be more with more applications. You can do MPLS traffic engineering, fast reroute, etc. The transport label is the LDP label. So that's going to be the first one you're going to want to remember. Transport label is always LDP. And tells the service provider core routers which PE traffic is destined to. So who is the exit point? Typically derived from LDP, sometimes called the IGP label, because you're tying that to you're using IGP to do route propagation, and then you're also leveraging LDP to do the mappings for that. Now, the VPN label tells the PE router which CE traffic is destined to, derived from the VPN v4 advertisements of PE. This is also referred to as the VPN label, also known as sometimes as the BGP label, because that's where the propagation comes from. BGP is the one that's actually doing the allocation of the routes being learned from the customer per label. Now, from a configuration perspective, as you can see, there's a lot that goes into this, and I'm not going to really go back through this because there's a lot of individual things to detail out. So I'm actually going to go ahead and minimize, and I'm going to go ahead and log back in here, and we are going to take a look at the topology that we have so far. And my intention here is to show you, scroll down here a little bit and scoot over. So right now, as of right now, we have IS to IS fully deployed. We have LDP fully deployed. We have BGP deployed on our provider edges and to our route reflectors. That's all working right now. And then we've also configured VRF-A on all of the PE routers. So from all the building blocks, we have all three of our MPLS layers of our layer cake done. So we have IGP, LDP, BGP, VPN v4. And then for our top 3 layers for MPLS VPN, we have the VRF. Now the next layer in this is going to be outside of the service provider environment. We're going to spin up a connection between 37 and 64 and 65 and 38. So what I'm going to do is I'm going to quick pause. I'm going to go ahead and boot these guys. I'm going to boot these guys up, get them squared away. I will do some initial configuration. I'll get some route peering squared away here. I'll probably just use EIGRP or something similar to that, and then we'll do the same thing over here. So I will pause right now, and then we'll go through and dive into standing up BGP between these two to get that process going. It's actually not very complicated. It's just going to take a few minutes to do. So I'm going to go ahead and do that, and then I will bring you guys back in here in just a moment. Okay, so I was able to get the devices configured, so we are good to go there, and I will walk you through what the config looks like here in just a moment once I this guy's squared away here. Scoot this up to the top. Alright, so the process is going to be pretty straightforward. What I'm planning on walking you guys through is we're going to configure 64 and 65 on gig 3 and gig 4 respectively with their own VRF. So it'll be just like we did in the previous video with the VRF config, so you guys can see the entire end-to-end process VRF, and then we're going to do BGP routing between 64 and 37 and 65 and 38. On 37, what I'm going to do is enable EIGRP here, and then we're going to see what it looks like to do redistribution between BGP and EIGRP and EIGRP and BGP. So we'll do a mutual redistribution between the two protocols here. And on 38, I'm going to take the learned routes from 18 to 38 via EIGRP, and then we're going to use the network statement in BGP to propagate the routes. So let's start from the provider side and work our way out. Okay, so we're going to start on 64, and I'm going to go to global config. I'm going to go to interface gig 3. I'm going to immediately put this into the VRF, and I'm going to specify the IP address here, 10.37.64.64/24. I'm going to no-shut that interface. We're going to give that a moment to come online, and then once it's online, I've already got 37 and 17 and 38 and 18 configured. So I'm just going to do a quick ping to verify that there's reachability. So it's going to do ping VRF-A 10.37.64.37. Assuming that everything's done correctly, I can ping across, which means 37 is responding, which is exactly what we want to see. The next stage I'm going to go through and do is I'm going to exit out of here. I'm going to type in the router BGP 10, and I'm going to type in it's going to be address family IPv4 VRF A, and hit the enter key. Now I'm underneath the address family for VRF A. If I type in here neighbor, it's going to be 10.37.64.37 remote AS, and then whatever AS we're going to use. In this case here, I don't have one defined. I'm going to use 65037, just so that it's easy for us to do. That is literally all the config I need to do. So I'm going to type in do show run section BGP. This is the VRF aware configuration for BGP that you're going to need to be aware of and need in order to do the peering. Now I'm going to jump over to 37. So let me go to global config, and I'm going to turn on router BGP 65037, and I'm going to type in neighbor 10.37.64.64 remote AS of 10. Now, because it's it's CE or customer edge configuration, I am going to go ahead and let the normal process work. So if I do show run section BGP, we're doing the most basic deployment there is, right? I've got the default BGP IPv4 unicast enabled globally, so it's automatically going to try to form a peering out of the gate via IPv4 unicast, which is what we want to have happen. Now what I'm going to go do is I'm going to go to between 37 and 17. I'm going to type in router EIGRP 10. I'm going to type in network of 10.17.37.0, 0.0.0.255. Very, very simple config. Same thing on 17. Let's go back to 17. Router EIGRP 10, network of 10.17.37.0, 0.0.0.255. Now these guys should form an EIGRP adjacency, which they will. And if I go back over here to 37 and I type in do show IP route, we're not learning any routes yet from 17. So what I'm going to do is I'm going to go back over here and type in do show IP interface brief. And I'm going to type in network of 10.17.0.0.0.255.255. Now I could get more specific with my network statements and just do like a summary range for these. If I figured out what this would be /23, this would be /22. But just for the sake of making my job easier, and let me go ahead and turn off the audio bell. If I go along with this network statement here, and this site grows, and I create more subnets, the loopbacks are simply just a way for me to simulate more local networks than are actually here. So I don't have to go out and connect switches to this and have them individual connections and all other garbage. I can just create more loopbacks. It's a logical subnet. It just allows me to propagate. Now by doing that, if I added 14, 15, 16, and 17 in the third octet, they're automatically going to be enabled for EIGRP. So if I do that, and I go back to 37, and I hit the up arrow, we should now get 4 subnets. We've got 10, 11, 12, 13, which is exactly what I want to have happen. So now that I've got that there, and if I do show IP BGP summary, I have a BGP peering. Now, this is where you have to get to the redistribution point. Now, we really haven't talked about redistribution up to this point in the series. In the playlist, there's going to be redistribution videos, but up to this point in the series, I really haven't gone into any real depth of how redistribution works. I'm going to talk about that in its own like miniature dedicated area, but the simplicity of this is this. As long as there's routes in the routing table, they are candidate for redistribution. That's the key thing. You can't take a route from like the BGP table that isn't in the routing table and make it a candidate for BGP redistribution. That's not how redistribution works. So what I'm going to do underneath EIGRP, I'm going to type in here redistribute BGP, and then the AS is going to be 65037, and then I need to set the metric for this so the EIGRP knows how to calculate the route. So it's going to be metric, and then I'm just going to come in here and put in some values that I know are going to be acceptable. Okay, there's that. So that's the redistribution process, and now I need to go underneath router BGP 65037, underneath address family, or underneath. I can do it globally because I haven't done anything special here. This is the most basic BGP configuration you can do. I'm simply going to come in here and type in redistribute EIGRP 10. That's all I need to do. Now, if I do show IP BGP summary, I'm not learning any routes here, but if I type in do show IP BGP, you'll notice that I have 4 routes in my routing table. This is my BGP table. So I've got these 4 routes. They're locally. Now if I go over to 64 and I do this, I do it show BGP VPN v4 unicast all, hit the enter key, I have 4 subnets. Well, technically 5. If you count the transit link between 37 and 17, I have 5 subnets on my routing table. If I type in show IP route VRFA, I have 5 BGP routes in my local routing table. Now, if I go to, say, R32, I do a show BGP VPN v4 unicast all, I should have 5 routes on my BGP table, which I do. Now, if I go over to 65 and do a enable show BGP VPN v4 unicast all, I have 5 routes in my BGP table. Right? So everything's looking pretty good up to this point. Let me go ahead and turn off the audio bell. There's got to be a way of disabling that. Anyway, so there's that. So I'm going to do the exact same thing on 38 and 18. So let's go knock that out real quick. So on 38, I'm going to go to global config and type in router EIGRP10, network of 10.18.38.0.0.0.255. So just enable EIGRP there. And then on 18, router EIGRP10, network of 10.18.0.0.0.0.255.255. So I should be able to form an EIGRP adjacency, and then 38 should learn a bunch of routes from me. Do show IP route, and I do. Now what I'm going to do here is, again, I'm going to do the network statement on 38. So I'm going to go to router BGP 65038, and I'll type in network of 10.18.10.0 mask /24. And then I'll do the same thing for 11. And I'll do the same thing for 12. I'll do the same thing for 13. Okay. Now, the next thing I have to go do, since I'm under BGP now, is I have to go type in neighbor of 10.38.65.65 remote AS of 10. So do show run section BGP. That's my configuration thus far. I come over to 65, go to global config, router BGP10, address family IPv4 VRFA, the neighbor of 10.38.65.38, remote AS of 65038. Hit the enter key. Give that a moment for it to do its thing. Okay, that's right. Do show IP interface brief. I don't have an interface configured yet. So gig 4, interface gig 4. Type in VRF forwarding is A. IP address here is going to be 10.38.65.65/24. And no, shut that. We'll wait for that interface to come online, and then we should be able to form a BGP peering back and forth. Interface is up, and then we should have BGP should form as well. Perfect. Okay, now let's go back to 32. We just hit the up arrow. Now we have routes 10. We got all that connectivity in place. Everything's looking pretty good. So everybody's happy. Now let's go over to 17, and I'm going to do a show IP route. Notice how I have some external routes. I have 10.18.10, 10.18.11, 12, and 13 respectively. So what I'm going to try to do is I'm going to attempt to ping 10.18.13.18, sourcing from loopback 13, and see what happens. Whole lot of nothing. Now, why is that? Why am I not seeing anything? So what subnet do I not see? I don't see this subnet right here. I need this one. This is transit, because right now, if I was to try to do a trace route, let's do this, do a trace to that destination and do it numerically. Trace, oh, that's because I'm going to switch. So trace route, IP, 10.18.13.18. Source is 10.17.13.17. Yes, I want to do numeric display. So here's what ends up happening. I end up getting to, I hit 37, then I hit 64, then I hit 30, then I hit 31, then I hit 65, then I hit 38. But the problem is there's no route between these guys. So to fix this, I need to go back over here to 38. And I need to type in another network statement of 10.18.38.0 mask /24. Now if I go back over here to 17, as soon as that route propagates, our trace route will complete. Because right now he doesn't know about the prefix. That's the problem. So I will look at 32, hit the up arrow. 38's there. 17 is now, should be completing here very, very soon. So if I look over at 18 and I do a show IP route, he is, oh, that's cute. So this is one of the problems that you run into here. Even though that 38 has a peering, he's not doing any redistribution into EIGRP. So what I've got to do underneath router EIGRP 10, I have to redistribute BGP 65038 with a metric of the same values I basically gave in the. There's that. So now 18 should have those routes, and he does, and then 17 it completes. So what ends up happening now is, and so what I ended up doing on router 38 is I hadn't redistributed. I did a network statement propagation on 38 of the learned routes that I got from 18 to 38. I advertised those to 65, but 38 was receiving these routes in, but wasn't passing them down to 18. Therefore, we weren't able to propagate. So we had to push the routes down to switch 18. By pushing the routes down to switch 18, we got in good shape. So there's that piece. So you got to have end-to-end reachability. So if we look back at over here, we have all the routes we need in the routing table. Everybody's happy. So now let's go back over here to switch 17, and we're going to do this trace route again. I'm going to do trace route IP. Target is going to be 10, 18, 13, 18, 10, 13, 17, 13, 17. Yes, I want a numeric display. And we get to where we got to go. So the 3 hops in the middle are the ones we care about. Hops 3, 4, and 5. So hop 3, if we notice here, we have 6518, 6518, 6518. 6518 is the BGP label we learned from 65. 3005, 3105 are the transport labels, the LDP labels that 31 got to get to 65 and 30 got to go to 31. So that's how that comes into play. You can look at this on 65 if we were to jump out of global config. If you're never not sure how this works, just do show BGP VPN v4 unicast all. And then for that particular prefix, all you have to do is 10.18.13.0 and hit the enter key. And what you're going to get when you do a detailed look at it is you're going to have MPLS labels, and you're going to have this little breakout right here. This is the in label, which applies to this guy. The out label applies to this guy. So the way that you want to look at this is BGP went ahead and allocated, when it learned the route in from router 38, it allocated 6518 to the 10.18.13 network. It works for me. Gets the job done. Now, if we were to look at it from this perspective and do show MPLS forwarding table, you're going to have a couple of interesting outlooks. You're going to have these routes right here. These are VPN routes. So what you want to be cognizant of is this. We have this prefix right here. This is obviously for 10. If you see this right here, this means that it's a VPN learned route, and the label that it's been associated to it is 6515. Now, the reason why that's important is because that's the BGP label. When BGP learned the route from R38 on 65 inside the VRF, the BGP VPN v4 process allocated that label to that prefix. Now we're doing a label per prefix. We could do a label per VRF as well. The label mechanism can change. And the way you would do that is you can do a VRF definition A, and then you can do the address family IPv4 unicast. You can do the that I don't remember how to do that. There's a way to change the label allocation mechanism. It might be under BGP. I forgot how to do that. IPVRF A. No, that's not it. I don't think it would be BGP. That would be like a next top value. So I could go to router BGP. There's a way to do that. I just forget how to do it. But the router BGP 10 under address family IPv4 VRF A you can do the it's not underneath this one either. I forgot how to do that. It's been a while since I've done it. There is BGP options as well you could add in here, but they're not specific to what we're trying to do. So there is a way to do that. Actually, give me 1 second. Okay, so the command is, it's MPLS specific. So it's MPLS label mode all VRFs, or in this case here be VRF A protocol, and then we're looking at BGP, VPN 4, and then you would do per VRF, right? And if you did a per VRF, and then we did a show MPLS, or so I'm sorry, show BGP, show MPLS forwarding table, what will end up happening is you notice how all those labels went away, right? Then you get 6520 is, no matter what we do, if we go back over here to 17 and we run that command again, we should see 6520. And now notice the label process is tighter, where we don't have that last process come into play here. Now that's more an advanced feature. I wouldn't recommend, I mean, it would be good for you to know it, but it's not like life and death. But if you get a question on how to change that, that's essentially what you would end up doing. It's a pretty straightforward process. So now that we have this in our back pocket and we know what to do with it, I'm obviously going to save my config. But what we'd be able to do in the future, because we have a full mesh deployment or any communication with our route target values and on all of our VRFs, is as we were to get this site online and operational and then bring in these two routers here and get them communicating with MPLS and all that good stuff that goes along with that, we'd start to see a bunch of more routes coming through. And that's really what we want to end up seeing as we go along. So we're gonna keep it pretty basic as we proceed forward. We have the MPLS VPN built now, which is important. But now that we have that in play, it gives us more flexibility in terms of the end-to-end operations. So as I'll bring a lot of this equipment back online. Some of the stuff I'm going to have to reconfigure probably because I don't remember if I saved the configs or not. So I'll rebuild a lot of this, get it back online. The cool thing about this now is when we get into more advanced topics for EIGRP, OSPF, and stuff like that, this will start to make more sense because you'll see, instead of me just describing, okay, DMVPN multi-cloud, for example, with a single hub, then this is how you would, get that into play, going over both the internet and both over MPLS, and a bunch of other capabilities that go into play with it. We're using BGP as our PE2CE protocol right now, and that's really what you need to be aware of anyway. So there's other capabilities and options as we get further along. They're just, these are going to be a lot of things that you will need to play around with. And like I said, we're not just fixated to the blueprint itself. We're going to be taking a look at different use cases and things like that. So if there's something, you got a question on something and you're not quite sure how to attack it, let me know and I will be happy to go through and walk you through that process and help eliminate any issues you might be having and stuff like that to try to fast track your success rate. So if you guys have any questions, comments, concerns, feedback, drop that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you awesome people in the next video.